Hello everyone, this is Vani, Department of Computer Science from PVC Siddhartha College. In this session, I'm going to share with you the real world applications of data structures. So in this last session, where last sessions can be what is the data structures, how it is the data structures has been classified, and the how many types of there in the data structures, and what is the uh, linear and non-linear and primitive and non-primitives of the data structures. So come to the in these sessions, so we are detailed explained in the applications of data structures and the non-primitive data structures. So first one is the arrays. We already know that arrays means how it can store the elements in the same data types of it does not allow the different types of data items. So first one example is image processing. Image processing comes under to that having the different levels. So it can be divided into that grid lines. In that grid lines are the pixels, where the pixels of an image can be represented into the two-dimensional array. So that means it can allows the efficient manipulations and analysis. So where comes under to the database management systems. In the database management systems, arrays are allows to the databases for storing a records in a tabular format. For examples, we can fix a number of peoples to that session. If for example we can take in a session to that 20 peoples has to be attended that session. So for that 20 peoples of the data has been fixed. So now we are entering in a data into the excel sheet or in a table. The 20 peoples of in a data document can be stored into that records can be stored into the excel or the table. That means we are before we are defining that we can fix it the size of an arrays. So comes to next comes to that second one, linked list. In that linked list it can be there are the two types of applications, not only two, there are the more than two. We can detail explain into the two types of linked two applications of an and linked list. First one is the dynamic memory allocations. In the dynamic memory allocations means it can be, we are already know that before we are using an elements it should be for or performing an dynamic memory allocations functions, we should be defining the either in a data structure or not. So used in the scenarios where the number of elements has been known before it. Example, managing a in memory applications. So in linked list it can be access the nodes from the dynamic memory allocations which is available or not. Where comes to the second application, implementation of an under features. That means applications like text editors use it as a linked list to store the history of changes. Whether we are texting to then some persons or any other persons, the first message is linked to the second messages, where second like and message was linked to the third messages either in the whatsapps or social media snapshots or the Instagrams, any other social media chatting accounts. We should there are the each message was linked to that another messages. So these are the one of the applications comes to that linked list. Where come to the stacks, we already know that stacks having the one endpoint insertions and deletions can be deletions at that the one endpoint either push or pop methods. So first application means function call management. The call stack keeps the track of activating functions or methods in programming languages, allowing for the recursions and backtracking. Recursions where and backtracking means we are number of times has been repeated the one repeated process. So the means we are again and again calling that elements we are deleting and inserting that same element number of times. So in that programming in a different programming language, either C or Java or Python. So recursions where the backtracking means sometimes where it is last be previously stored and backly stored, and we can track that either forwardly or and backtrackingly. So recursions means how many number of times we are repeating that element, whether it is stored and deleted. So comes to that expression where comes to expression evaluation. We already maybe you should know that infix expressions and postfix expressions and prefix expressions. So infix expressions to postfix expressions means where we are changing an equation's value to storing an into that stacks values. Sometimes all elements are not to be stored into that stack values, so that's why we are not only changing the values, we are just conversions of an expressions into that infix to postfix. It can be also performed that same expressions where they're from the original expressions, it is evaluations by the only to the compilers, it can only used in that compilers. Where comes to the queues comes where the we already know that queues can be insertions or deletions can be at the two different points. First one is the front end rear. In the job scheduling means we are scheduling in some certain time whether to be executed or processing time or completions of an processors in that operating systems. So in operating systems as queues manages the operations waiting time for an executions or the resources. There are the different job scheduling algorithms. First in first out round scheduling algorithm, job scheduling algorithm. That means an processor should be executed or waited to the resources from the whether it is free of not. Next, come to that print spooling, where queues are handle the prints jobs sent by the to the printers and ensuring they are processed in that order they will be researched. That means printer spooling space. Firstly, it accepts the whether where printers was given instructions. For example, two systems can be connected to that first, single printer. The from the first systems it passes the 10 printing copies to that printers, and second systems again sends the 5 prints to the printers. It firstly it allows to the which printers comes into that ender time. It can be calculated by the instructions or jobs sent to that from systems to the printers. Though so these process can be, we can call it as queues. Next comes to that hash tables. That means hash tables means we are indexing of any data or the tables. So examples means they in the real world applications database indexing. So in the we already know that why we are using indexing. We are indexing and some value to the from this page to the this taking an example of a textbook. So in the textbook in defining the indexing means from this page to this one. So this some chapter or a name or a chapter or unit 1 or unit 2 unit 3 unit 3, or again it can be classified into the topics. It starts from this page to the this page or so that means we are indexing before we are not turning that or searching the topic before we, by using the indexing we are directly go to the data. So we can directly accessing the data from the eh, by using the indexing. So database indexes means hash tables are allows for the quick data retrieval based on unique keys and improving the database for the every query performance. So retrieving means unique keys means all data having that not only same pages numbers. For examples, here is the 4 is the we know here is the fourth. For this document it can be it's to be fourth page. Where comes under to the next page means it's to be fifth page. That means every page having that unique numbers and continuations of numbers. So these can be comes to that hash tables. Now second exam second real world applications comes to the enhanced tables means caching. Web browsers and applications are used as the hash tables to cache frequently access the data from the quick access. So web so for example we can use that any searching of an topic in a web browser, so we can easily different types of websites that are available. For examples, we are searching of an data structures introductions. So we can search in a data structure introductions. It shows the different pages, different websites or applications, what they providing their informations. That means it is also stored in that their websites and providing to that user interfaces. So these can be Catching means by using the hashtags or the name of an we are searching, it can be interlinked to the databases into the web servers and web browsers. So these are can be considered into the hash tables. So next comes to the trees. So in the trees having that there are the different tile levels of the trees. That means we insertions or deletions can not only be easily possible in the or implementations in the trees. So trees can be can be used into that in real world applications. Means we can use that file systems. So hierarchical structures in the file systems are implemented using the trees to organizing the file directories and the directories. So for examples for each team, if we can comes to that taking as an example of in a software development teams, there are the different types of levels. So by categorizing their project names, there in that project names there are the team every there are the five teams are working on that project. For each five teams having the 10 people, so they can be they categorized into the different levels. So that means for each uh, uh, each batch having that 10 peoples. That means each in the where the 10 peoples may be classified either working or developing or researching on that projects. That means we are taking an example of a project title. In that project title there are the five batches or the teams are working in. For each team, each people having that 10 members, each team having that 10 members. So we can classify these can be considered into that trees. Next comes to that search engine. Binary trees are the other trees to helping this in the indexing and searching for an web pages efficiently. Searching engines means we can directly accessing for example we are not only for we are searching an applications of an data structures in web browsing, so it can be interlinked to that either introductions to the data structures or the not only real world applications, it can be applications in a data structures in that data tables, data structures nodes has to be in the either linear arrays. So we are all searching for the arrays, linked lists, stacks, queues, hash tables and trees. So we are searching and real world applications in that web browsers. It can be shows the not only real world applications, it can be also displays the trace or queues or applications in another websites. That means search engines means we can easily it can for we are searching and indexing or searching or anything topic in a web browsers, it can also interlink to the another topics to that matter. So that's why this can be considering to that trees. Now go to that graphs. In that graphs there are the we are defining the social networks. Social networks means node represents users and edges represents connections, friendships like followers, enabling. So in social networks having the different types of theirs, either WhatsApp or Instagram or Facebook or Twitter, or there is the more number of applications are in the social networks. For example, we are considering to their either YouTube channel or the Instagrams or Facebooks. There are the friends, mutual friends, followers and following posters are the yeah, these are all linked to that persons only. Whether he they can be that person can be decided to be a private or public, or they can share the images to that followers to the another people or not. Now where it comes to that heaps, there are the different types of heaps are there. uh, Lower heap and higher heap. So priority in lower heap means higher heap means there are the highest node can be placed into the first level and lowest one can be considered into the child nodes. So these heaps can be used into that these can be used heaps into used in that trees also. So first one is the priority queues and memory management. In priority queues, the used in algorithms like distributed first, that means depth first. That means it mainly used in the graphs. And memory management can be used means heaps manages memory allocations in the dynamic programming ensuring the efficiently proper memory usages. For examples, we are taking in a systems in our system, so it can be allocated the first we can sort out by the highest storage. Not only in our systems, we can search in a mobile phones. In our mobile phones we can sort out by the either A to Z or the highest